There is another very easy way of finding an expression for escape velocity. See, just listen to me. When the body which has been projected with the escape velocity has already gone out of the gravitational pull of Earth, what would be its potential energy? Potential energy, do we have a formula for potential energy which is mgh, right? So potential energy, there is no oscillation due to gravity anywhere outside the gravitational pull, so it will be 0. Moreover, what will be the value of kinetic energy? The body has already gone out, and if it is still not moving, if it is stationary, then there won't be any velocity, and hence the kinetic energy will also be 0, right? So total energy in space of a body will be 0, that is potential energy plus kinetic energy. Now, according to law of conservation of energy, this is the second way of deriving the same relation. Law of conservation of energy. Total energy at Earth, that is potential energy plus kinetic energy at, I'll write down here, Earth is equal to total energy in space, right? Which is potential energy plus kinetic energy. This is equal to 0. I already explained to you what is potential energy. We did the gravitational potential, that was minus g m over r, and what is kinetic energy? Half m v square, which is escape velocity. So this thing goes there, I'll get half m v square is equal to g m over r, and hence, see, we got the answer in just one step. 2 gets multiplied here, ve square is equal to 2gm upon r, or escape velocity is under root 2gm upon r. Okay, now one more thing, we have got the formula for this escape velocity, which is under root 2gm upon r. See, I hope you can just pause the video and note it down. See, what I wanted to tell you is there are what are the other formulas for VE, that is escape velocity. The formula we just figured out was under root 2gm over r, right? Okay, let's change it. What is first phase? What is g? This is gm over r square. Therefore, gm is equal to gr square. Put this value here, I'll get 2g r square over r, and this is one of the most commonly used formula, which is under root 2gr. This is escape velocity. Another formula. This is 1, this is 2. One more. If in here I put mass to be product of density and volume, because density is mass per unit volume, that means mass gives volume into density. So 2g, and instead of m, volume 4 upon 3 pi r cube multiplied by density, right? Volume into density. This is what? Upon r. So here we had r only, right? We had 2g, I wrote it down, upon r, wrote it down, and m is volume into density. Yeah, this is only. So this is the new formula. This becomes 2. We have, I can take out r square, the r outside, but I'm not doing that. I'm just writing the whole thing. 4 into 2, 8 upon 3 pi g rho r square upon, that's it, 8 upon 3 pi g rho r square. So this is another formula for escape velocity. So you can do it only when what is given? When the density of the planet is given. No, we cannot solve it any further. We cannot simplify it any further. Just we can do one thing. We can replace the value of gr square with something else. Then it will go back to the same picture. So this is the final formulation.